Balancing off chemical equations. Earlier, we have learnt the law of conservation of mass, which states that mass can neither be created nor destroyed in a chemical reaction. It means that the total mass of the elements present in the reactants of a chemical reaction is equal to the total mass of products present in the reaction. In other words, we can say that the number of atoms of each element remains the same before and after a chemical reaction. Thus we can define balancing off an equation as the process of making the number of different types of atoms equal on both sides of an equation. Let us take an example to understand the balancing off an equation. This reaction can be written in words as hydrogen, on combining with nitrogen, gives ammonia. We can change this into a chemical equation by writing the symbols and formulae of various substances in place of their names, as shown. Here, H2 stands for hydrogen gas, N2 stands for nitrogen gas, and NH3 is the chemical formula of ammonia. In this reaction, H2 and N2 are reactants, whereas NH3 is the product. Let us count the number of hydrogen atoms and nitrogen atoms in reactants and product. From this, we observe that the number of hydrogen atoms in reactants is 2, but in product it is 3. And the number of nitrogen atoms in reactants is 2, but in product it is 1. To balance the equation, let us multiply H2 by 3 and NH3 by 2. So, we have 6 hydrogen atoms on both the sides, that is, reactants, as well as product. Now, this equation contains an equal number of hydrogen atoms. And the number of nitrogen atoms is also equal on both the sides. So, this is a balanced chemical equation. 2 or more reactants combine to form a single product is known as a combination reaction. Let us take one example to understand the combination reaction. Take a small amount of calcium oxide in a beaker. Slowly add water to this. Touch the beaker with your hand. Do you feel any change in the temperature? You will feel that the beaker is warm. This is because calcium oxide reacts vigorously with water to produce slaked lime. That is, calcium hydroxide, releasing a large amount of heat. In this reaction, calcium oxide and water combine to form a single product, calcium hydroxide. Hence, it is a combination reaction. Decomposition reaction. The reaction in which a compound splits up into 2 or more simpler substances is known as decomposition reaction. Let us take one example to understand the decomposition reaction. Take about 2 grams of ferrous sulfate crystals in a dry test tube. Note that the color of the ferrous sulfate crystals is green. Heat the test tube over the flame of a burner. Observe the color of the crystals after heating. Do not point the mouth of the boiling tube at yourself. In this reaction, the green color of ferrous sulfate first changes to white, because it loses water molecules, and then changes to brown, due to the formation of ferric oxide. A smell of burning sulfur is obtained due to the formation of sulfur dioxide gas. The reaction is 2-FeSO4, on heating, gives Fe2O3, that is, ferric oxide, plus SO2, plus SO3. Hence, ferrous sulfate, on heating, splits up into three substances: ferric oxide, sulfur dioxide, and sulfur trioxide. So, this is a decomposition reaction. Let us study oxidation and reduction. The addition of oxygen to a substance, or the removal of hydrogen from a substance, is called oxidation, whereas the addition of hydrogen to a substance, or the removal of oxygen from a substance, is called reduction. Let us take an example to understand oxidation and reduction. When hydrogen gas is passed over heated copper oxide, then copper metal and water are obtained. The chemical reaction is written as copper oxide plus hydrogen, on heating, gives copper plus water. In this reaction, copper oxide changes to copper, because oxygen is removed from it. We know that removal of oxygen from a substance is called reduction, so we can say that copper oxide is reduced to copper. We also find that the reactant, hydrogen, changes to water, because oxygen is added to it. Now, addition of oxygen to a substance is called oxidation, so we can say that hydrogen is oxidized to water. In this reaction, copper oxide gives the oxygen required for oxidation of hydrogen. Therefore, copper oxide is the oxidizing agent, and hydrogen is responsible for removing oxygen from copper oxide. Therefore, hydrogen is the reducing agent. Thus in this reaction, one reactant gets oxidized, while the other gets reduced. Such reactions are called oxidation-reduction reactions, or redox reactions. Double displacement reactions. Double displacement reactions are defined as the reactions in which two compounds react by an exchange of ions to form two new compounds. Let us perform an activity to understand the concept of double displacement reaction. First, take about 3 ml of sodium sulfate solution in a test tube. In another test tube, take about 3 ml of barium chloride solution. Now, mix the two solutions. On doing so, you will observe that a white, insoluble substance, called precipitate of barium sulfate, is formed. The reaction, which takes place, is as follows. Here, barium ions react with sulfate ions to form barium sulfate, and sodium ions react with chlorine ions to form sodium chloride. Such reactions, in which there is an exchange of ions between the reactants, are called double displacement reactions. Also note that a reaction that produces a precipitate can be called a precipitation reaction. Here, barium sulfate is formed as a precipitate. Hence, this reaction is also called a precipitation reaction.